Hello everyone, I welcome you all to my channel Revealing Concepts. Today we are going to start with a new chapter, Coordinate Geometry of class 10th. So what exactly is coordinate geometry? It is also a branch of mathematics in which you actually plot points in two dimensions, and this points are used to describe various geometric figures. They are also used to describe or even to plot different curves like circles, parabolas, etc. This two-dimensional plane in which we are going to plot these points, that two-dimensional plane is called as a coordinate plane, or it is also called as a Cartesian plane. Now, how exactly does this coordinate plane looks like, and why do we call it as a two-dimensional coordinate plane? Let's see. So specifically in today's class, or the agenda for today would be learning the basics of coordinate geometry. Then we are also going to see distance formula. We are going to see the proof of this, and finally we are going to see the real life applications of this particular distance formula. The application of it in terms of mathematics or problem solving using distance formula would be done in the next class. But as of now, in today's class, we are going to look for the basics of coordinate geometry. We are going to see the distance formula, its proof, and where exactly it is used in real life. So let's start with the basics of coordinate geometry. Firstly, we are going to understand what exactly is a coordinate plane or the Cartesian plane. So any arrangement of this form, like wherein you have an x-axis, you have a y-axis, it is called as a coordinate plane. Now here clearly if you see, there are two axes denoting two dimensions. When you say 3D, there are three dimensions to any particular point, you would say, or a figure, and the third axis in a three-dimensional plane would be the z-axis. So this arrangement wherein you have two axes perpendicular to each other such that the horizontal axis is the x-axis and the vertical axis is the y-axis is called as a coordinate plane, or it is called as a Cartesian plane. Again, why the name plane? Because here if you see, this actually forms a plane. It is not a three-dimensional body, neither it's a one-dimensional body. It's a plane that you can see. Now, now that we have understood what is a coordinate plane, and I have told you that coordinate geometry deals with plotting points. So what exactly is this plotting points, coordinate plane, coordinate geometry linked together with? How they are linked together with? So they are linked together with something called as coordinate. So what exactly is a coordinate? Let's say that I number this x-axis as 1, 2, 3, 4, and since this is a line, it can be extended infinitely. Now, in a coordinate plane, to be very precise, the midpoint where both these axes meet each other is called as the origin, and it is having the coordinate as 0. The point over here is 0. Now, towards the right hand side of the x-axis, we have all the positive numbers, and on the left hand side, we have the negative numbers. Similarly, when you plot points on the y-axis, the points above the origin are positive and the points below the origin are negative. So we have 1, 2, 3 and 4. -1, -2, -3 and -4. Now the distance between each of this point is uniform. It is the same, just like you have seen it on a measuring scale. So this arrangement where you have two axes perpendicular to each other, wherein the horizontal one is called as the x-axis, the vertical one is called as the y-axis, with the right hand side of the x-axis having positive numbers, the left hand side having negative numbers, the y-axis with numbers with the numbers above origin are positive and numbers below origin are negative is called as a coordinate plane or a Cartesian plane. So this arrangement is called as a coordinate plane or a Cartesian plane. Now, if you see, this entire plane is divided into four parts. So we have 1, 2, 3 and 4. These are the four parts, and these four parts are called as four quadrants. So they are called as four quadrants. So a two-dimensional coordinate plane is always divided into four quadrants, wherein this is the first quadrant, this is the second quadrant, third quadrant and the fourth quadrant. Now I want you all to observe the first quadrant and tell me that the value, if you see first quadrant, it is restricted to this horizontal line and this vertical line. So here if you see, the x values are all positive and even the y values are all positive. So here if we want to take the values of x and y, and according to the alphabetical order also if we go, and if you want to place one x value in the front, one y value at the back, so we will always get x value as positive and y value also as positive. So in the first quadrant, you're going to have both the x value as well as the y value as positive only. So let's say if at all any point is given to you, let's say a point whose x value is 1 and y value is x value is positive and y value is also positive, and if you are asked to guess, or if you are asked to tell its quadrant, then you are going to say that since its x value and y value both are positive, hence it lies in which quadrant? It lies in the first quadrant. Similarly, if you move on to the next quadrant, that is the second quadrant, and as I told you, we would first write the sign of the x value and then we would write the sign of the y values. So here if you see, since we are talking about the second quadrant with its x values as negative and y values as positive, therefore in the second quadrant the arrangements of sign would be in this manner: negative and positive. So if somebody asks you that x is equals to -2 and y is equals to +3, where exactly does this point lie? So for you, this point lies in which quadrant? In the second quadrant. Similarly, in the third quadrant, both the values of x and y, that is this and this, both of them are negative. So you would have the arrangement as minus and minus. Whereas in the fourth quadrant, the x value is positive whereas the y value is negative. So you would have the arrangement as plus and minus. So this is how I would say a coordinate plane or a Cartesian plane would look like, wherein you would have a perpendicular arrangement of two axes, that is x-axis and y-axis meeting at point 0, where each point is located equidistant from each other on the axis. The entire plane is divided into four parts, which are called as the four quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant, and each quadrant has its own sign for x and y point. Like in the first quadrant, both x and y are positive. In the second quadrant, both x is negative, y is positive. In the third quadrant, both the points x and y are negative, whereas in the fourth quadrant your x is positive whereas your y is negative. So that is all about the coordinate plane. Now, I since the beginning of this lecture I am constantly talking about coordinate geometry, coordinate plane, Cartesian plane, but the word coordinate occurs again and again. What exactly is this coordinate? So let's understand the concept of coordinate also. Now let's say that if I say that there is a point over here, okay, I mark a point on the Cartesian plane or on the coordinate plane, and now I want to know what exactly is its position on this coordinate plane. So what I will be doing is, I would be seeing what is its x value and what is its y value. So how exactly am I going to know what is its x value and what is its y value? So I am going to drop a perpendicular from this point on the x-axis and from this point on the y-axis. So this is a perpendicular and this is a perpendicular. I am supposed to find its x value, its y value. So when I drop a perpendicular from this point on the x-axis and on the y-axis, I see that the perpendicular meets the x-axis at point 3 and y-axis at point 2. Since this point lies in the first quadrant, so it is very obvious that both the values of x and y would be positive. Now, if I want to locate the position of this point, as I have mentioned earlier, I would say that the location of this point is 3, 2. Now, this particular type of arrangement is called as the coordinates representation of a point in two-dimensional plane. So here if you see this arrangement where you are going to write the x value first, the y value second, separated by a comma and enclosed inside the curve brackets or the open closed parenthesis which we formally say, this type of arrangement is nothing but the coordinates of a particular point in a two-dimensional plane, wherein strictly the first point or first number is the x coordinate and the second number is the y coordinate. So when I say x coordinate, it corresponds to x value of that system and y coordinate corresponds to y value of that system. And you also call this arrangement 3, 2 as the tuple form. Now students, I want you all to know specifically about this coordinates. As I told you, this is nothing but 3, 2 basically tells you where exactly your point is on the coordinate plane. Because if I randomly draw a coordinate plane and I mark my point over here and now I say give me the location of this point, without numbering, without marking and drawing perpendiculars, you won't be able to guess its location just by looking. What dimensions are you going to give it, or how are you going to guess its position? So that is why numbering and then writing it in the tuple form is actually very, very important to locate the point. And hence this arrangement of a coordinate in terms of coordinates is also known as the address of this point. Now why it is known as the address of this point? Because it actually tells you where exactly is the point in the coordinate plane. I hope you are thorough with this concept of what is a coordinate plane and then what is a coordinate in a coordinate plane. Now, always keep in mind a coordinate is basically a pair arrangement of x and y value written inside the round brackets separated by commas, wherein the first value is the x value and the second value is the y value. It is also called as the tuple form in two dimensions, right? And it gives you the address or location of a point. Now that we know what is a coordinate plane, a coordinate in that plane, I'll tell you that the formal name for the x-axis is also called as the abscissa. So this first coordinate you would say, or the first point, that is the x value, is also called as abscissa, whereas the y value is called as ordinate. So if at all in exam the question comes that plot the point whose abscissa is 3 and whose ordinate is 2. So you're going to draw the coordinate plane and you're going to put the x value as 3, y value as, locate x ka value as 3, y ka value as 2 and mark the point. So your x coordinate is nothing but abscissa and y coordinate is nothing but the ordinate. I hope you all are thorough with this basic terminologies related to coordinate geometry. Once again, to revise, we started with coordinate plane. We moved on to what is a coordinate in a coordinate plane and what are the formal names that are given to every point in this coordinate. So now that you know these basic terms of coordinate geometry, let's move on to a very interesting concept of distance formula. Now, what exactly is this distance formula? To begin with, I would tell you that the main purpose or usage of this formula is to actually find distance between 2 points in a coordinate plane. So, let's say that if this is a coordinate plane and if there are 2 points in the first quadrant and if you are asked to find the distance between these 2 points, then how are you supposed to find this distance? So in order to find this distance, the mathematicians have come up with this formula known as the distance formula, and as the name suggests, it is the distance formula, meaning it tells you the distance between 2 points. So here if you see, they say that in a coordinate plane, let's say that you have 2 points, A as x1, y1 and B as x2, y2. So this is your coordinate plane, right? And if you have A as x1, y1 and B as x2, y2, and you are supposed to find the distance between these 2 points, right? So here the x coordinate of A is x1, y coordinate is y1, that of B is x2 and y2 respectively. So the distance between these 2 points A and B is given by the formula. You write it as AB equals to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the formula to find out the distance between any 2 points in the coordinate plane, be it this distance and this distance, any distance. It's not just that the two coordinates have to be in the same plane only. They can be in the same quadrant only. They can be in any quadrant. You just need to know the coordinates of both the points. If you know the coordinates of both the points, it is very easy to calculate the distance between both these points. Now, there is one more interesting fact over here, that let's say you have a point A as x comma y. So let's say this is a coordinate plane and you have a point A x comma y. This is our origin and the coordinate of the origin is 0 comma 0 in tuple form. Now, if at all you are supposed to find a distance between origin and A, what is the statement written over here? Distance of a point A x comma y from the origin. So you are supposed to find the distance of a point from the origin. Then how are you going to use the distance formula and find the answer? So here if you see, you know that the coordinates for A is x and y, whereas the origin ke coordinates are 0 comma 0. So here 0 comma 0 is your x1 and y1 and your x2 and y2 are x comma y. If I try to substitute this in this formula, so we have, let's say the origin is nothing but O. So OA would be equal to under root of x2 minus x1 square plus y2 minus y1 square, right? Now here your x2 is x, whereas your x1 is 0, the whole square. Similarly, your y2 is y, whereas your y1 is 0, the whole square. So this is equal to under root of x minus 0 is x and the whole square. So you have x square plus y square. So with this we come up to a general formula of finding the distance between any point from its origin. So let's say you have been given two different points and if you are asked to find the distance between those two different points, you can use this formula. But if at all you have been given, find the distance between the given point and origin. So whenever one point is origin and another point is any other point in the coordinate plane, you are always going to use this formula, that is under root of x square plus y square, where x and y are basically the coordinates of the given point. So I hope you are completely thorough with the concept of the coordinate plane and the distance formula. Now we are going to see the proof of this distance formula. Now students, let us start with the proof for the distance formula. This proof won't be asked in the exam, but I am doing it just for your understanding so that you would get a conceptual clarity of exactly how the mathematicians arrived to the distance formula. So we would just roughly understand it. Here I have taken 2 points A and B with coordinates as x1, y1 for A and x2, y2 for B. Now we are going to actually get the distance between these 2 points A and B, and that would be nothing but the distance formula. So for that, first we have to do a small construction. That is, we have to draw a line parallel to y-axis and passing through point B. At the same time, it should be perpendicular to x-axis, meaning I have to drop a perpendicular from point B on x-axis such that this line is perpendicular to x-axis and it is parallel to your y-axis. Similarly, I have to drop a perpendicular from point A on the y-axis and it would be parallel to your x-axis. So here if you see, this is a perpendicular which is dropping on the y-axis. It is parallel to x-axis, and since this is a line, I can extend it from this side. Now both these lines, they meet at a point, say T. Now since we are supposed to find the distance between point A and B, that is why I am joining the points A and B with a straight line, which you can see. Now here we all know that this is a perpendicular line, this is a perpendicular line, hence the angle formed at point T would be a right angle. And if you closely observe that, then we have got a triangle ATB, which is a right angled triangle where your angle T equals to 90 degree. How we are sure that it is 90 degree? Because we have dropped a perpendicular from point B on the x-axis and it's parallel to y-axis. Similarly, we have dropped a perpendicular from point A on the y-axis parallel to x-axis and we have extended it towards its right. Okay, so both these lines meet each other at point T, and that is how we are getting a right angle triangle ATB, which is right angled at point T. Now I want you all to again closely observe that if I drop one more perpendicular from point B on the y-axis and a perpendicular from point A on the x-axis, right? Okay, so now if you see, if I drop a perpendicular from this point on the x-axis, so this is nothing but our x coordinate, right, of A. And what is the x coordinate of A? It is x1. Similarly, when I drop a perpendicular from point B on the x-axis, the point at which the perpendicular meets on the x-axis is the x coordinate of B, right? So this is your x2. Similarly, when I drop a perpendicular from point A on the y-axis, the point where the perpendicular meets on the y-axis is nothing but its y coordinate, and in this case it is y1, and this would be the y coordinate of B, that is y2. Now students, if I want to find out this distance, how much it would be? So this distance, knowing that this is, let's assume that this is 2 and this is 4, then the distance between 2 and 4 is 2. How do you get it? 4 minus 2. So similarly, what I'll be doing is, if you want to know the length of x1 and length between x2 and x1, so that would be x2 minus x1. Similarly, length between y2 and y1 would be y2 minus y1. So this is nothing but the length between these 2 points. Now students, carefully observe. This same length corresponds over here. So this value, I'm talking about this length. This would be also how much? Y2 minus Y1. Similarly, this length is equivalent or equal to this length, 80. Therefore, the value of 80 or the length of 80 would be x2 minus x1, right? So, here we have a right angle triangle ATB with side 80, length of side 80 as x2 minus x1 and length of side BT as y2 minus y1. Since it is a right angle triangle, hence by Pythagoras theorem, the hypotenuse square, that is AB square, equals to AT square plus BT square. Now, since we know the length of AT and BT, therefore we can substitute it as x2 minus x1 the whole square plus y2 minus y1 the whole square. Now, we want to find out what is the length of AB or value of AB. So in order to, but this is the length of, this is basically AB square ka value. So in order to cancel out this square, we are going to take square root on both the sides. So when we take square root on both the sides, the square and square root on the left hand side gets cancelled. And what we get is AB equals to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is nothing but the distance formula which we saw earlier in the definition of the distance formula. So here, once again, to sum it up with the proof, I first got a right angle triangle. Using the Pythagoras theorem, I actually came up with the distance formula. So the proof is pretty simple. You don't have to remember, you just have to understand the procedure of getting the distance formula. So with this, we come to the end of today's class, and before ending today's class, I would want to mention about what exactly are the real life applications of coordinate geometry. So earlier when I started the lecture, I told you that when we talk about a coordinate in a coordinate system, a coordinate point in a coordinate system, it actually gives you the address of that particular point. So when I say x1 comma y1, right, it actually helps you to locate the point, that yes, when your x1 is equal to 3 and when your y1 is equal to 2, my point would be in the first quadrant and exactly at so and so position. So it gives you the address of a particular point. So a very basic and simple application of the coordinate geometry, the coordinate system, the coordinate plane would be in GPS. We all know GPS, we all use Google Maps. So they are being designed on the logic of coordinate geometry only, wherein every location is mapped based on the coordinates, right? Even the map navigation that I have told you, Google Maps, they are being designed in such a way that if anybody wants to find out the location, then the software actually gives you the location based on the coordinates of that particular location. Similarly, it is also used in the airline industry. Now, how it is used in the airline industry? To actually plot the trajectory. What is the trajectory? Basically, the path followed by the plane. So, let's say that there's a plane which has been flying in the sky, and now what they are going to do is they want to find out, let's say a plane goes missing. Okay, this is a hypothetical situation, and a plane goes missing, but they know that yes, at so and so time this plane was over here, then later on it went over here, finally it we found it that the movement, the coordinates of those plane are basically moving in a downward direction. So these positions have been determined using the coordinates which are there. So depending upon the coordinates of the position of a plane, they try to actually trace the path that has been followed by the plane, and that is how you come up with different conclusions. Similarly, it is also used for military purpose. Now, how it is used for military purpose? First of all, depending upon the map, the military of one nation tries to place its soldiers depending upon the coordinates. So every soldier is placed strategically strategically using different coordinates, so that chief knows that so and so soldier is placed at so and so coordinates. Similarly, they try to understand the coordinates placing of their enemy as well, so that they would strategically attack them and try to gain win over them. So right from your GPS, Google Maps to airline industry, and even in the defense, we would say there is a wide and vast use of coordinates. So this is actually a very important topic which you all must be well aware and well known of. So students, with this we come to the end of today's class. In the next class we are going to actually solve problems using the distance formula. So we are going to actually see how distance formula is used in the field of mathematics. Thank you so much and see you the next time.